Hello there and welcome to the video. We're going to answer lots of questions on solving trig equations with sec, cosec and cot in them. So just a reminder of the rules that we're going to be using in this video. Sec is equivalent to 1 over cos. So wherever you see sec, you can write 1 over cos. Cosec is 1 over sine and cot is 1 over tan. And the little trick you can use to remember this is that it's always the third letter. The third letter corresponds to the trig function that it's equal to. So the third letter in sec is C, C for cos. The third letter in cosec is S, S for sine. And the third letter in cot is T, T for tan. Another rule that we also remember is that sine over cos is equal to tan. But you can also flip that rule upside down and say, well, 1 over tan is cot, and then the flip of the reverse of the fraction, the flipped fraction, is cos over sine. So if you ever see cot, it might be helpful to refer to this as cos over sine. Another rule that we remember from A-level maths in the first year is that sine squared plus cos squared equals 1. And if we take this identity and divide everything by cos squared, so I'll divide this by cos squared, divide this by cos squared. We're effectively dividing both sides by cos squared here. Divide this by cos squared. Well, what do we get? Well, sine over cos is tan. Sine squared over cos squared is tan squared. Anything over itself is 1, and 1 over cos is sec. 1 over cos squared is sec squared. So we get another identity, and that's this one here. Tan squared plus 1 equals sec squared. And it's like a baby identity from the big identity, which is sine squared plus cos squared equals 1. This one is tan squared x plus 1 equals sec squared. And we could do something very similar. Don't divide by cos squared this time, maybe we'll divide by something else, sine squared. And we'll get a third identity relating to quadratics. So if we divide everything by sine squared over sine squared, that's just something over itself, which is 1. Cos over sine is cot. Cos squared over sine squared is cot squared. And 1 over sine is cosec. 1 over sine squared is cosec squared. So we get a third identity relating to quadratics, which is 1 plus cot squared equals cosec squared. And we can always use these 6 identities, these 4 as well, wherever we wish to in these sorts of questions. So let's get started on the first one. So hopefully what we'll do is we'll go through question by question, try and pause the video and have a go at the question before I attempt it, and that way you'll be really kind of testing your own abilities and making more progress than you would if you were just watching the question be answered. So let's look at the first one then, pause the video and give it a go. I'm just going to jump straight into it. I'll just check here that my calculator's in radians mode because my domain goes from 0 to 2 pi. And when it says 2 pi, it's referring to radians. So I'll just check my calculator's in radians mode there. Now, what we would do if we had the button on our calculator is do sec inverse of 2. But sec is not a button on our calculator. So what we'll need to do then is we'll need to turn it into 1 over cos equals 2, because sec is 1 over cos. Then I'll multiply both sides by cos, so I'll get 2 cos x equals 1 on the left hand side. Divide by 2. And now I've got cos x equals a half. So we know that what we can do then is we can do cos inverse, because cos inverse is a button on the calculator. And that will give us, let's just do it on the calculator just to make double sure. Cos inverse 0.5 is pi by 3. Then we need to work out second solutions in between 0 to 2 pi. So this is what the cos graph looks like. We'll put our benchmark of a half on the side there, go across and down. That will give us our solution of pi by 3. Second solution will be all the way over here. So we've gone a distance down from the peak of pi by 3, so we'll come down from a distance of this peak by pi by 3. This peak here is at 2 pi, so it's going to be 2 pi minus pi by 3, which will be 5 pi by 3. So the two answers to this question are pi by 3 and 5 pi by 3. And there we are. So in the range from 0 to 2 pi, those are our two answers. So this is how we do these sorts of questions. Then if you've got sec equals 2 or cosec equals something or cot equals something, then just rewrite it as 1 over something, multiply to the other side, divide your number to the other side, and solve it as a normal trig equation. So move on to the next one then. This one here is a 1 over sine function. 1 over sine x equals root 2. Times sine onto the other side, so it would be root 2 sine x. Divide by root 2 onto the other side, you get 1 over root 2 is sine x. The next thing we do is we then do inverse sine, and we'll get pi by 4. And then working out the second solution in between 0 to 2 pi, it's going to be a curve that looks like this. 1 over root 2 will be somewhere up here. So our first solution is pi by 4. Looking across to the second solution, it will be somewhere here. This intersection point here is pi. So the little distance that we've gone up the sine graph by is pi by 4. So I have to come back by that equivalent amount from pi. So the second solution here is pi minus pi by 4, which is 3 pi by 4. So our two solutions to this equation then is pi by 4 and 3 pi by 4. And there we are, that's the answer to this equation. Moving on to the next one, still in radians mode, so this is going to be a 1 over tan equals minus root 3. Multiply tan onto the other side and we get minus root 3 tan x equals 1. Divide by the minus root 3, so that would be minus 1 over root 3 equals tan x. The next thing we'll do is we'll do inverse tan of minus 1 over root 3, inverse tan minus fraction button 1 over the square root of 3. And we'll get minus pi by 6. This won't be a final answer because our answers are in between 0 to 2 pi. So let's draw out that tan graph. At least going up to 2 pi. 2 pi will be here, pi will be here, 0 will be here. What we've got so far is a benchmark of 1 over root 3. That will give us an answer of pi by 6, minus pi by 6. And to get to the next solutions, to minus 1 over root 3, you just add pi onto your answer each time. The tan graph is a pretty easy one to use. So add pi onto this one, you get 5 pi by 6, and add another pi on and you get 11 pi by 6. So these here are the two answers in between 0 to 2 pi. Okay, so let's move on to the next question. We've got sec x equals minus root 2. We've got a bit of a weird domain here, but we're still in radians mode, so I won't touch my calculator yet. So this is 1 over cos x equals minus root 2. So I'll multiply the cos onto the other side. And I'll divide by the minus 1 over root, but divide by the minus root 2 to give me minus 1 over root 2. The next thing I'll do is inverse cos it, so it's going to be inverse cos on the calculator here, minus fraction button 1 over root 2, close the bracket, and it's 3 pi by 4. Okay, well that will be not a final solution because we're looking for solutions in between minus 2 pi to 0, so it's going to go backwards like that. At the moment, I've got a solution at minus 1 over root 2. That will give me this solution over here. This would be 3 pi by 4. So the first solution that I'm going to work out here will just be symmetrically on the negative side of this curve here. So it would be 3 pi by 4 downwards in the negative direction instead of going downwards in the positive direction. And now I'll come forwards by 2 pi to get the next solution. Forwards from minus 2 pi to get to the next solution. So the next solution is, so the first real solution will be minus 3 pi by 4, and the next one will be minus 2 pi add 3 pi by 4 which will be minus 5 pi by 4. So this is first, that's the second final solution, this is the first final solution. So there we are, those are the two answers to this question. Let's move on to the next one. In between minus pi to pi now, so we're going to write here 1 over sine x equals minus 2. Next thing we'll do is we'll multiply by sine onto the other side. Then we'll divide by minus 2. The next thing we'll do is we'll do inverse sine of it, so inverse sine minus 0.5, and that gives minus pi by 6. So let's work out what the next solutions will be. So the sine graph looks like that, in between 0 to pi, this in between 0 to minus pi. So at minus a half, I've got a solution at minus pi by 6, and I'll get a second solution over here. This will be minus pi over here, so we'll come back by the distance of pi by 6, forwards by the distance pi by 6 rather, so this will be at minus 5 pi by 6. So our two solutions here are minus pi by 6 and minus 5 pi by 6. So there we are, that's the answer to this question. Let's move on to the next one. Right, so we've got x plus 30. We're back in degrees mode. So the first thing I'm going to do is change my calculator back into degrees mode. The next thing I'll do is I'll sort out the angle, because the angle inside your domain must be the same as the angle inside your cosec. So this is going to be from 390 rather, not 330, 30 to 390. Okay, so that's the angle. This is going to be 1 over sine x plus 30 equals 2. And the next thing we'll do is we'll times by that sine x plus 30. And then divide by 2. Then we do inverse sine, so the angle of x plus 30 is going to be inverse sine of a half, which is 30. Because sine of 30 gives you a half. Then we look for next solution, so we need to make sure we've drawn the graph at least from 30 to 390. I'll start from 0, because then I know at least I've covered it, and I'll finish up here. So this is going to be at 180 here, 360 here. You do need to go in between radians to degrees pretty effortlessly once you've got good at it. The last point on this graph here will be 450. So I've at least covered from 30 to 390. I've covered from 0 to 450. So my graph is going to give me my first solution at 30. My next solution will be, well, if I go forwards by 30 from the base, I'll come back by 30 from the base. So my next solution will be 150. And there might be another one up here. If I come forwards by 30 degrees there, I get another solution of 390. So that will be my next solution. And all three of these solutions are valid because we've got equal to on the inequality. So it could equal 30 and it could equal 390 as well. The last thing I need to do is, because 3x plus 30 was all of these angles, to find x, I need to take away 30 from all of these angles. So it's going to be 0, 120, and 360. And there we are. These are the three answers to this question. Okay, so let's move on to the next one. So the first thing I do here is I realise that I'm back in radians mode. So I'll grab my calculator and switch it back to radians mode. The next thing I realise, I've got 2x inside here, so I'll need to change my angle in the domain to that same unit of 2x. So I'll double the middle, double the left, and double the right-hand side. So the next thing I need to do is I'll need to write this as 1 over cos 2x equals 2.35. Then I'll times both sides by cos. And then I'll divide by 2.35, so I'll write it as 1 over 2.35. Probably, strictly mathematically speaking, that's not correct. You shouldn't mix decimals and fractions together, but I'm just doing a part way through work here. So my angle then is going to be 2x, and that's going to be equal to cos inverse of fraction button 1 divided by 2.35. A fraction, the calculator can handle that, that's fine. 1.13. Now I know here I'm going to have to continually refer to this 1.13 because it's actually on the calculator as 1.1312467334. So what I'm going to do is I'm going to press the STO button and then I'm going to press the negative number button to store it as the red letter A. So I've now stored the 1.1312467334 as variable A on my calculator, so I can keep on referring to it. Why would I need to do that? Well, because I need to find more solutions. So I need to draw my graph for cos in between 0 to 4 pi. So that's going to be 2 loops through of the cos graph. So this will be at pi, 2 pi, 3 pi, and 4 pi. So my first solution to 1 over 2.35 was this solution here, 1.13. My next solution will be all the way up here, so I've come forwards by that amount of 1.13, so I now have to come backwards on the graph by that value of 1.13, so my next solution for 2x is going to be 2 pi minus 1.13, or the actual calculator value of 1.13, which is the big long decimal. So I'm going to write in my calculator 2 pi minus a, and that would be 5.15 to 3 significant figures. The next solution, if I carry this graph, my solutions onwards, it will be moving forwards from 2 pi by add 1.13 from 2 pi. So now I'll do 2 pi add a, because a is stored as the exact value of 1.13, and that will be 2 pi add 1.13, which is 7.41. And the final solution, it looks like if I carry on this set of solutions forward, I'll get another solution, and that will be from 4 pi coming backwards by that amount of 1.13. So it would be 4 pi minus the value a on my calculator, which I've now just done, 4 pi minus 1.13, which will give me 11.4 to 3 significant figures. Right, so all of these answers here are my answers for what the angle would equal. In this case, the angle would be 2x. So now I need to work out my final answers for x. So what I'll do then is I'll go back to A, use my calculator, use the up button to go back to A, and for the first one I get 0.566. The next one I'll have to go back to doing 2 pi minus a and then divide that by 2. So 2 pi minus a, and then I'll divide that by 2. And that will give me 2.58. Maybe what I should have done is when I calculated these exact values, divide them by 2, because I've then currently got them on the calculator, but now I'm having to retype them in. So I'm kind of wasting a little bit of time here, aren't I? 7.41, but then divide that by 2, and we get 3.71. And the final one will be 4 pi, take away the value a, and then divide that answer by 2, and we get 5.72. So there we are. These are the 4 answers to this question here. Right, so let's move on to the next one. So the first thing I've spotted in this question here is that it's in degrees mode. So that's the first thing I'll set up on my calculator, degrees mode. Right, this question needs rearranging. So the first thing I'll do is I'll move the 2 cot x onto the other side. The next thing I'll do is I'll rewrite 2 cot x as 2 over tan x. What students will typically do is they'll think, well, it's 2 cot, so therefore it must be 1 over 2 tan. That's not correct. It's 2 times cot, 2 times 1 over tan. That will make it 2 over tan, not 1 over 2 tan. Okay, so make sure you don't make that silly mistake there. Let's rub that out. So it's 2 over tan. Next thing we'll do is we'll multiply the tan onto the other side. And then divide by the 5. And lovely, we've got tan equals 2/5. So now in degrees mode, let's solve this equation. Tan inverse 2 divided by 5. And the first solution there will be 21.8 degrees. Now for a tan graph, let's just remind ourselves of what we do for tan. For 180 it will be this section of graph here. For the output of 2/5, we get an answer of 21.8 degrees. If we were to add 180 onto it going to the right, we'd run out of room. It would be outside of our domain. So we need to, on this solution, subtract 180. So I'm going to do answer minus 180, because our domain is in between minus 180 to 180, and I get minus 158 degrees. And there we are. Those are the two answers for this question here. Let's move on to the next one. So in this one here, first thing I need to do is keep my calculator in degrees mode and take away 60, because my angle is x minus 60. So it's going to be from 300, so I have to take away 60 on all sides, down to minus 420. The next thing I'll do is I will start rearranging this. So root 3 sec x minus 60 will turn into root 3 over cos x minus 60 equals 2. Sec is 1 over cos, and it's root 3 times 1 over cos, so the root 3 will stay on the top. It won't join the cos on the bottom. That would be a typical student mistake there. The next thing I'll do is I'll multiply the cos onto the other side, so it'll be 2 cos x minus 60, and then divide by 2 onto the other side. Lovely, and there we are. Now we have an equation that can be solved. The next thing I'll do is I'll do inverse cos of square root of 3 divided by 2, close brackets, and I'll get 30. So my angle, which is x minus 60, is equal to 30 degrees. Now let's work out the next solutions to this equation. So it's a cos graph, so it's going to go through one rotation of 360 to the right, one rotation and a little bit more on the left hand side, because this will be minus 90, minus 180, minus 270, minus 360, minus 450. And I want to make sure that I've covered the whole range of this graph here. So I've gone down to minus 450 to make sure I've covered everything. And this graph here obviously goes up to 360 on this side. So I've covered the whole range in this graph. So my output here was root 3 over 2. So I'll go down and across. That was my first solution of 30. Next one would be this over here. So when I've found this 30 degree angle, I've come down from the top by 30 degrees. So I'll have to come down from this top by 30 degrees. And if I've started at 360, I'm down to 330. On the left hand side, if I go left by, well, I've got three solutions on this side. If I go left by 30 degrees, I'll be at minus 30. If I come down from minus 360 by 30 degrees, I'll be at minus 330. And if I go backwards from 360 by 30 degrees, I'll be at minus 390. And all of those solutions there are inside this range. No, this one is not. This one is not inside the range, so I can ignore that one. And the last thing I'll need to do then is I'll add 60 onto all of these answers. So add 60 onto 30, I get 90. Add 60 onto minus 30 and I'll get 30. Add 60 onto minus 360, I'll get minus 270. Add 60 onto minus 390 and I'll get minus 330. And there we are. That's the answer to this question here. Let's move on to the next one. So the first thing I'll do is change my calculator back into radians mode, because from the domain I can see it's in radians mode. The next thing I'll do is I'll change my domain into a half x, because my angle in this question is a half x. So I'm going to look for answers in between minus pi by 2 to pi by 2. The next thing I'll do is I'll start to rearrange this now. So it's going to be 2 over sine x over 2, or half x, and then I'll move the 7 onto the other side, so it'll be equals 7. Now remember, 2 cosec is actually 2 over sine. It's not 1 over 2 sine. It's 2 times cosec, so it's 2 times 1 over sine. Then I'll times the sine onto the other side. And divide by 7. And there we are, lovely. We've now got x over 2 equals 2 over 7. So now I will find out what my angle will equal. My angle is x over 2, and I'm going to do sine inverse 2 divided by 7. 0.290, because it's 2897. The 7 around the 9 up to a 10, and the 9 around the 8 up to a 9. So 0.290. Okay, let's find second solution. So we're looking on the sine graph here in between 0 to pi by 2. Pi by 2 will be there, minus pi by 2 will be down to here. That's only going to be one solution. So the next thing I need to do is realise that's only one solution. So I'll double my answer to actually work out what x is, and that'll be 0.580. Yeah, so 3 significant figures. That's the only answer to this question. Alright, let's move on to the next one. Well, this looks like a difficult one here. Back into degrees mode then. That's the first thing I'll switch over. Back into degrees mode. And I will then change my angle to make sure it's the same in the domain. So I'll double it first, so 2x. Double of 0 is 0. Double of 360 is 720. And then I'll take away 18, so it'll be minus 18, 2x minus 18, and that'll be 702 on this side here. Lovely. I think just because I don't really want to write out 2x minus 18 every time, I'm going to replace this with the letter y. Okay, so in this question I've now got sec of y equals minus 1.3. Let's rewrite this as 1 over cos y. And then divide, so times both sides by the cos, and then divide by the minus 1.3. Okay, and now I'm going to find out what y could equal. So it's going to be cos inverse, just checking again degrees mode, minus fraction button 1 over 1.3. Close brackets, 140. And what I'm going to do, because I can sense that it's 140.2848628, I'm going to store this. I'm going to press the store button, STO, and then I'm going to press A, and I'm going to store 140.2848628 as value A on my calculator, because I can sense I'm going to work out a lot more solutions here. The next thing I'll need to do for the cos graph is I'll need to draw it in between minus 18 to 702. So I'll go back a little bit here, and then I'll do two full rotations of the cos graph. So this will be up to 720. I'll do it all the way back here to minus 90. So this will be 90, 180, 270, 360, I'll jump a few, 540, jump a few to 720. So my first answer here was my output here was minus 1 over 1.3, so it's down the bottom. So I've got this solution here, I'll get another solution here, I'll get a third solution up here, and I get a fourth solution back here. So how did I get to those solutions? Let's use a different coloured pen to highlight this. From the peak, I've come down by about 140. So I've added 140 from the peak there. So to get to my next solution, I'll come backwards by 140. For the next solution, I've come forwards by 140 from the peak on the right-hand side there. And then from the final solution, I've come backwards from 720 by 140 to get to that solution there. So y is also going to equal 360 minus 140. So 360 minus a on my calculator, 360 minus a, that will give me 220. And I round to three significant figures. 360 add 140, which would be 500. And 720 minus a will give me 580. Okay, so now with each of these, this is my value for y, but y is equivalent to 2x minus 18. So what I now need to do is I now need to work out what x is. So for the first one, I'm going to take 140 and I'm going to undo this operation here to work out what x is. So I'm going to take my value for a, then I'm going to add 18 to it, and then divide it by 2. I've done that all on the calculator, and then to three significant figures my answer is 79.1. The next one was this 220 solution here, and how did I get that? It was 360 minus the value a, so I'll retype that into the calculator, and I've got the actual value of 219.71151372. Then I'll undo this operation here, so we add 18 and then divide it by 2, so that to three significant figures is 119. The next answer was from 360 going forward by a, so it's 360 add a, and then we need to undo this operation here, so that will be then add 18 to the answer, then divide it by 2, and we get 259. And for the last one, it was 720, take away the value a, and then we add 18, and then we divide by 2, and we get 299. Whew, and there we are. That was a lot of work done on the calculator there. Make sure you followed that through with your own calculator, making sure you can do it as well. Done a lot of work there off screen, so make sure you can do those sorts of questions as well. Right, okay then, let's move on to the next question. So we're still in degrees mode here, and the first thing I need to do is sort out the angle, because I want my domain to have the same angle. So it will be double the x values to start with, so minus 360 to 360, and then add on 135 onto all three components. So minus 360 add 135 will give me minus 225, and on the right hand side 360 add 135 will give me 495. So when I find my solutions, I need to make sure I'm covering this region here. I don't really fancy writing out 2x plus 135 every time. I'm going to write the letter y in this time. So it's going to be from minus 225 up to 495 are my answers for the angle, which I've replaced with a y letter. So the first thing I'll do then is I'll write this as 1 over tan y equals 1, then times the tan y onto the other side. So I get 1 equals tan y. The next thing I'll do is I'll work out what y is equal to, and y will be equal to 45 degrees. The next thing I'll need to do is I'll add or subtract 180 degrees to work out next solutions. So 45 add 180 will be 225. And I'll continue to add 180 until I've gone out of the boundary. 405. And I won't bother adding another 180 because it would definitely be out of the range. Go back to 45 and take away 180 this time. So I've got some negative solutions, minus 135, and then take away another 180 just to see if it's inside the range or not. Minus 315, outside of the range, not an applicable answer. So these are my 4 answers. So these are equivalent to 2x plus 135, the angle that's inside tan. So So the next thing I'll do with each of these is I'll now subtract 135 from each of them. So 45 take away 135 will be minus 90. 225 minus 135 will be 90. 405 minus 135 will be 270. And minus 135 minus 135, yeah, 2 minus 135 is minus 270. And the next thing I'll do is I'll divide all of these by 2 to get my final answers. Minus 45, 45, 135, and minus 135. And there we are. These are the answers to this question. Okay, so moving on to the next question. First thing I've spotted is this question is in radians mode, so I'll change my calculator to radians mode. The next thing I need to do then is turn this into a sine or a cos. So cosec, the third letter is S, so it's going to be sine, and it's going to be 1 over sine squared equals 4. I'll times the sine squared to the other side and divide the other side by 4, so it'll be 1 over 4 equals sine squared x. And the next thing I'll do is I'll square root, so it'll be a half equals sine x. Square root the 1, you get 1, square root the 4, you get 2, square root the sine squared, you get sine. But don't forget that when you square roots, you've got to do a plus or minus. So actually in this question we get 2 questions for the price of 1. We get sine x equals a half and sine x equals minus a half. So in the first half we're going to get 30 and 150, and in the second half we're going to get 210 and 330. And I'll just check that last one just to make double sure. Oh, sorry, I've done it in degrees mode, haven't I, silly me? So in this question it's going to be x equals pi by 6. It's going to be 5 pi by 6. X is equal to 7 pi by 6, and the last one will be 11 pi by 6. Let's just check that last one. Sine of 11 pi by 6, just to make sure I've got it correct. Minus a half, yes, that was the correct one. So I've got 4 solutions here, this one here, this one here, and just make sure you don't do a silly mistake like I have and done it in degrees mode when the answer here is clearly in radians mode. So there we are, that's the answer to this question. Let's now move on to the next one. So this one's a quadratic one, and I reckon we'd probably be able to put this in brackets. Don't worry about turning it into 1 over cos yet. We'll put it into some brackets first. Still in radians mode. So I think here we're going to do minus 3 and plus 1. So here either sec x equals 3, we've got 2 equations for the price of 1 here. Sec x equals minus 1. Now with both of these I'll turn them into 1 over cos x equals 3 and 1 over cos x equals minus 1. Then I'll do some multiplying and dividing and get a third equals cos, and minus 1 equals cos. Okay, so now I need to solve these in between minus pi to pi. So the graph, let's just put the graph in the middle. The graph is going to go down like that and down like that on the left hand side. So when I solve the first one, cos inverse, checking for radians mode again, 1.23. So at the third, I've got an answer of 1.23, and this will be symmetric on the other side, minus 1.23. So x is also equal to minus 1.23. And for this question on the right hand side here, the only time it's equal to minus 1 will be at the bottom of both of the graphs, so that will be x equals pi, and x equals minus pi. So 4 answers here. We've got the 2 here, and we've got 2 over here as well. Lovely, there we are, that's the answer to that question. So put your sec, cosec or cot in brackets, and then sort it out afterwards. Don't Don't bother with multiplying through by cos or anything like that to start with. Okay, let's move on to the next one, and this one's looking a little bit tricky. I think what I'm going to do here is, I've got cot on this side, cot on this side. I definitely won't be cancelling out the cots, because cots can sometimes be 0, and you don't want to ever cancel anything out that could potentially be 0, because you'll be dividing by 0, which is which you're not allowed to do mathematically. So what I'm going to do with this one is I'm going to bring everything onto the left-hand side. And then it would be taking away 6 cot x equals 0. And the next thing I'm going to do, instead of dividing by cot, I'm going to factorise cot. And if you divided by cot in this question, you got the answer wrong. You have missed some of your solutions. So cot x, and then it would be cosec x minus 6 equals 0. So we've got two equations for the price of one here. We've got two components that are multiplying together to make 0. So one of these components must equal 0. Either cot x equals 0 or cosec x equals 6 to make the bracket equal 0. In which case sine x will be 1 over 6. And maybe you've got familiar now with doing that cross multiplying of the sine and the cos and the tan. So I've now got two equations to solve. In between minus pi to pi, well actually what I could do here is I could say that this would be 1 over tan. Hold on, we need to do this one slightly differently, don't we? Cot x equals 0. So let's just remind ourselves of what cot is. Cot is cos x over sine x equals 0. And the only way this fraction would ever equal 0 is if cos x was equal 0. So when does cos x equal 0 in this range from here to here? It would be a minus pi over 2 and pi over 2. So that was a little bit tricky there. I didn't have to give that some thought as to how you would solve cot x equals 0, because you wouldn't be able to times the other side by tan, because you can't times tan by 0, because otherwise you'll get an equation that says 1 equals 0. So you need to treat it as cos over sine, and then if you've got a fraction that equals 0, it's the numerator that equals 0. No matter what the denominator is, it won't affect an answer being 0 or not, in which case you get minus pi by 2 to pi by 2. Let's carry on this side. So it's going to be inverse sine 1 over 6. Let's make sure I'm in radians mode. Yes, I am. 1 over 6. And I get 0.167. And to get the next solution, it's pi minus this. So pi minus answer, 2.97. And because the sine graph in between minus pi to pi is only positive on the left-hand side, on the right-hand side, I'm only going to get solutions for 1/6 on this side. 0.167 and 2.97 over here. So there we are, we have 4 answers. These 2 answers here and these 2 answers here. Lovely, there we are. That's the answer to this question. Okay, so moving on to the next question. First thing I'll check is radians mode. Yeah, all good on that front. And we've got a mixture here of cosec and sec. So I'll convert both of them back into sine and cos. So it's going to be 1 over sine equals 4 over cos. Make sure you're not making that silly mistake of writing 1 over 4 cos, because it's 4 times sec, 4 times 1 over cos. So it's 4 times the 1 on the top, and cos will be on the bottom, so it'll be 4 over cos. Now in this question what we're looking for is to somehow create tan, and remember that tan is equal to sine over cos. We could create cot, but that would just lead us to doing it in a longer method. So we want to create sine over cos. So what I'll do then is on both sides I'll multiply by sine. Show you why in a second. Multiply by sine. And if I multiply the left hand side by sine, I'll just be left with the 1 that's on the top of the fraction. On the right hand side it will be multiply the sine onto the top, and I've got this thing here. Now I've created a sine over cos, and sine over cos is tan. So it's now 1 equals 4 tan x. Then I'll divide by the 4 on the other side, and I've now perfectly got a little trig equation that's solvable. I've got 1/4 equals tan x. So I'll plug this into the calculator then. Inverse tan 0.25, and I've got 0.245. And the way that I'll find the next solution on a tan graph is just by adding pi radians. So that will give me 3.39. And there we are, these are the two solutions to this equation. So what we did first of all was we turned them into sine and cos, multiplied both sides by sine to make it sine over cos, because sine over cos can turn into tan. Leave the 4 alone at the front, and then divide the 4 on the other side to make yourself a little equation. Alright, let's move on to the next one. Let's rewrite these two in terms of sine and cos. And remember that cot is 1 over tan, so tan is sine over cos, so it's that identity upside down, so it's cos over sine. The next thing we'll do is we'll get rid of the fraction by multiplying both sides by sine. So it'd be 2 cos sine on the left hand side. So I've multiplied both sides by sine, and then equals, if I've multiplied this side by sine, then I'll just have the cos left on the numerator. Now what you should not do on this question now is to cancel out cos on both sides, because you'd be cancelling out something that could potentially be 0, and you can't ever divide by 0. The way you do solve this though is you move the cos onto the other side by taking it away. So you'll be left with nothing on the right hand side, then you factorize it. So it's cos x, because cos x is a common factor, 2 sine in the first term, minus 1 in the second term equals 0. And now you've got two expressions that are multiplying together to make 0, so it's either cos x that equals 0, or sine that's equal to a half, because that's what will make the bracket equal 0. Two equations here, we now need them solved. So on the left hand one it will be pi by 2 and minus pi by 2 in this domain, and this one here is going to be pi by 6 and 5 pi by 6. And there we are, these are our 4 solutions here. So the key takeaway from this question was to turn them into sine and cos, rearrange to get rid of the fraction first of all, don't cancel out cos, take it onto the other side and factorize it, and then you'll get more solutions, in fact all of the solutions to this equation, rather than just this set of solutions on the right hand side here. You'll get these 2 extra ones because you need all of them. Alright, let's move on to the next one, and the next one is 3 different components in degrees mode. Let's change my calculator first of all. Degrees mode it currently now is, and I'll rewrite all this out with sines. So it's 5 sine, that will stay the same. Then it'll be minus 2 over sine equals 3. Now I need to get rid of the fraction, so what I'll do is I'll multiply everything by sine. So I'll multiply this by sine, this bit by sine, and this bit by sine as well. So it'll be 5 sine squared minus 2 over sine times sine will just be 2 equals 3 sine x. I've multiplied everything by sine. And now what I can create is a little quadratic. If I take away the 3 sine onto the left hand side, equals 0. Now I'll open up my 2 brackets. And it's going to be minus 1 and plus 2, because that will give me minus 5 sine plus 2 be plus minus 3 sine. So now I've got 2 brackets. If 2 brackets are multiplying to make a 0, one of the brackets must equal 0. So it's sine x equals minus 2/5, or sine x equals 1. In my range, the only time that sine x will equal 360 is at 90 degrees, And then let's solve this one. Grab the calculator, sine inverse minus fraction button 2 over 5, close brackets, equals minus 23.6. Now what I'll do is I'll store that as the value for a. So store as a. That's minus 23.6 I've stored. But I'm looking for answers in between 0 to 360. So that's the sine graph. So if I've got a solution at minus 2/5, then what the calculator's given me is this negative expression down here, which is minus 23.6. So if I want the solutions in between 0 to 360, I need to move onwards by that amount from pi, or I need to move backwards by that amount from 360. Sorry, did I say pi there? I meant 180. So to get this solution up here, I need to do, I'll write it down here. It would be x equals 180. Now it's a negative value, it's minus 23.6, so I'll have to take it away to make sure I've got a double negative effect to move it forwards up there. So it would be minus 23.6, the current value that I've stored as a. So I'm going to do 180 minus a on the calculator, and that will give me 204 to 3 significant figures. And the next solution will be 360. And this, I do want it to go backwards, so I'll add the negative number on. So it'll be add the number minus 23.6, the current answer I've stored as a. So it'll be 360, add the value a, and that will give me 336. So what answers are there for this question? We've got 204, that's an answer. 336, that's an answer. And 90 degrees, that's an answer. Minus 23.6 is not a correct answer for this question because my answers are in between 0 to 360. And there we are, that's the answer for this question. The key takeaway for this is turning it into sine first and then spotting that if I multiply all three components by sine, then I get myself a quadratic, solve the quadratic, boom, nice and easy. Okay, and let's move on to the next one then. In the next one, I think I'll write everything out first of all as cos and sine. So 1 over cos equals 3 sine over cos. And in this case, I've got two fractions where cos is the denominator on both of them. And if the fractions are equal to each other, then it must be the case that the numerators are also equal to each other. Because if the denominators are equivalent, then the numerators must also be equivalent if the whole fractions are equivalent to each other. You could effectively say you're timesing by cos here on both sides as well. Let's divide through by the 3 on the other side. And now before I do inverse sine, I'll check I'm in radians mode. I actually missed that step out at the start of this question, so I always check and then do inverse sine of 1 divided by 3. And in this case I get x equals 0.340. That's correct to 3 significant figures. And then I need to look for second solutions on the sine curve. That will be looking like that thing there. So I'm going up by 0. This would be a third. 2 solutions on the positive side. This would be going up by 0.34. So I have to come back by that 0.34 from pi. So it's pi minus answer. That will give 2.80. 2.80, and all those answers are correct to 3 significant figures. No negative solutions here because it's on the negative side of the axis. Alright, let's move on to the next one, and I think the first thing I'll do here is I'll write cot as tan, actually, because I've got tan on the other side, so it'd be helpful if everything was in terms of tan. 5 over tan. And the next thing I'll do is I'll multiply by tan. So 4 tan plus tan squared, I'm multiplying everything by tan here, equals 5, because 5 over tan times tan is just 5. And now we've got ourselves a quadratic. Let's write it as tan squared x plus 4 tan x and then we'll minus the 5 onto the other side, equals 0. Lovely. So now I'll put it in some brackets and I'll cross my fingers that this does work. I think it will be plus 5 and minus 1. And that, just check the middle bit there. Yeah, that's 4 tan x. So either I've got tan x equals minus 5 or tan x equals 1. Let's solve these equations. For the first one, it's going to be 45 or 180 added 225. For the next one, I'll need to use the calculator. Make sure I'm in degrees mode for this question. So it's going to be tan inverse minus 5, and that will give me minus 78.7. That won't be a final answer because it's not in the correct domain, so I'll have to add 180 to move it up a solution, 101, and then add another 180 to move it up another solution, 281. So I've got 4 answers here, these 2 answers here, and these 2 answers here are all 4 answers to this equation. Let's now move on to the next one. And I think in this one I'll convert everything into sines and coses. So it'll be 1 over sine plus 5 cos over sine equals 0. The next thing I'll do is I'll multiply everything by sine. So it'll be 1 plus 5 cos equals 0. So therefore cos, if we take away the 1 and divide by 5, will be minus 1/5. So the next thing we need to do is then change our calculator into degrees mode. Just make sure I'm doing that good. And then it's going to be inverse cos minus 0.2, or minus 1/5. And that'll be 1.77. Now I'll check for second solutions. Cos graph looks like that. This will be at pi, this will be at 2 pi. So I've currently got a marker at minus 1/5, so my solution is going to be here and at here. And the way I'll work out the other one is I've gone from a peak down by that 1.77 to get to this solution here. So I have to symmetrically come back from 2 pi by that 1.77. So the next solution here is going to be x equals 2 pi minus 1.77. I'll put answer button when I use this in the calculator. 2 pi minus answer will be 4.51. And there we are. These are the 2 solutions to this equation. Right, okay, let's move on to the next question then. We have tan squared minus 2 sec x minus 2 equals 0. And let's just check we're on the calculator in degrees mode. Let's just change that. Right, okay, so here's what we're going to do for this question. In a very similar way to the ones we did where it was cos squared and then a sine later on, we're going to turn tan into something sec-y. Now we remember that sine squared plus cos squared equals 1. I don't really want to fancy writing it all out, so I'll just write s squared plus c squared equals 1. I'm then going to create a tan. So to create a tan, I need sine divided by cos. So I'm going to divide everything by cos here. And then sine squared divided by cos squared, well, that would give me tan squared. Anything divided by itself is just 1 equals, and then 1 over cos, that's sec squared. So, to be able to turn a tan squared into a sec squared, if I take this 1 onto the other side, it's going to be tan squared equals sec squared minus 1. And you can always use this identity here. It's one you can either remember, or it's one you can quickly create from sine squared plus cos squared equals 1. So, in this question, I'm going to replace tan squared with sec squared minus 1, because I know the 2 things are equivalent. So, in the next line is going to be sec squared x minus 1 minus 2 sec x minus 2 equals 0. Let's now simplify this. Sec squared x minus 2 sec x minus 3 equals 0. And you can see what I've created here. I've created a quadratic in terms of sec. It's always going to be the linear one, and you always transform the quadratic one. This one will change, and this one will stay the same. Let's now factorize it. Sec x minus 3 and sec x plus 1. So I've now got two equations for the price of one here. I've got sec x equals 3, or in other words, cos x equals 1/3. Or I've got sec x equals minus 1, in which case cos x equals minus 1. So for the first one, I'll grab the calculator, cos inverse, check I'm in degrees mode again, because I wouldn't want to make that mistake. 70.5. And then it's going to be 360 minus this, to get the second solution, 289. For the second solution, it's just going to be x equals, it starts from the top, 180, because that's when the cos graph reaches minus 1. It's only at one point at 180 degrees. And there we are. These are the solutions to this equation. So the key takeaway from this question is that you change the quadratic term into the linear term by one of these rules here, linking sine squared plus cos squared equals 1. In this case, we divided it all by cos squared to get tan squared plus 1 equals sec squared. Rearrange it a little bit and you can replace tan squared with sec squared minus 1. Quadratic in terms of sec, carry on from there. Let's have a go at another very similar one here. So in this case here, we are going to want to turn the quadratic one into the cot one. So let's start with sine squared plus cos squared equals 1. And I want to create cosec. And the way I create cosec is 1 divided by sine squared. So if I divide everything by sine squared, what will I get? I'll get sine squared over sine squared, which is just 1, plus cos over sine, that's cot squared, equals cosec squared. So this is another identity that you can either remember or you can quickly create it like I have here. So in this question, I'm going to be replacing cosec squared with 1 plus cot squared. So it's going to be 2 bracket 1 plus cot squared, and then plus 2 equals 9 cot x. This question's in radians mode, you need to make a mental note of that. Expand the brackets, I'll get 2 plus this other 2 here, which will be 4. 2 times cot squared, and then I'm going to take away the 9 cot x onto the other side, equals 0. Let's now factorize 2 cot x and cot x. Looks like it will be minus 4 and minus 1. The minus 4 on this side to create a minus 8 cot x, and then minus another one, minus 9 cot x. Lovely. So here we get two equations for the price of one, either cot x equals a half, in which case tan equals 2, or cot x equals 4, in which case tan x equals 1/4. Now let's work out the solutions to these. The first thing I'll do is I'll make sure my calculator's in radians mode, and then I'm going to do inverse tan of 2, which will give me 1.11. And then I'll add on pi, because that's how you get to the next solution on the tan graph, 4.25. Then I'll go back and redo the quarter one, or do the quarter one now. Tan inverse 0.25, 0.245. And then I'll add on pi onto that one to get the next solution on the tan graph. You get 3.39. And there we are. These are the solutions to this equation here. And the key takeaway for this one was once again to turn the quadratic part into the linear part by using a rule that's associated with sine squared plus cos squared equals 1. In this case, it's 1 plus cot squared equals cosec squared. Let's move on to the next one. And in this one, we could turn one of them into the other one. There is a rule, if I just look backwards, I can cheat. 1 plus cot squared equals cosec squared. 1 plus cot squared x equals cosec squared. So I can choose which one would I fancy turning into the other one. I think I'll turn cosec into cot, so I'll do it this way. 1 plus cot squared x plus another cot squared x equals 3. Tidy up and take away the 1 onto the other side, so it'd be 2 cot squared equals 2. So therefore cot squared x equals 1. So therefore cot equals plus or minus 1, because we have to do a plus or minus when we square root. So either tan equals 1 or tan equals minus 1. Now let's work out the solutions in radians mode in between minus pi to pi. So for the first one, it's going to be 1.11. I'm pretty sure we worked that out in the question before, yep. And then to get to the next solution, we're actually going to have to subtract pi here. So tan inverse 1, and then take away, oh sorry, that was pi by 4. Well, that was tan equals 2 there. And then we'll take away pi, so minus 3 pi by 4. And then for this one here, it's going to be x equals minus pi by 4. And then add on the pi by 4, you get, add on the pi, you get 3 pi by 4. So there we are, a little hiccup with that one there. But we're okay. We're okay. It's pi by 4 minus 3 pi by 4 minus pi by 4 and 3 pi by 4. Lovely, let's move on to the next one. And in this one, it's again one where we have to turn the sec squared into a tan. So I remember it's 1 plus tan squared equals sec squared. So to turn the sec squared, it's going to become 1 plus tan squared. So it'd be 1 plus tan squared x plus 2 tan x equals 0. I'm just going to write this in a different order to make it look more like a quadratic. And this, I think it's a tan x plus 1 tan x plus 1. So we've got a repeated root here, so tan x is definitely going to equal minus 1. So then it's going to equal minus 45 degrees, and then add on 180 degrees to get to the next one. Minus 45 add 180, and we'll get 135. And these are the two solutions for this equation here. Alright, let's move on to the next one then, and it's again one of these ones where we'll have to turn the cot squared into a cosec. So the identity is 1 plus cot squared x equals cosec squared x. So it's going to be cot squared x equals cosec squared minus 1. So replace cot squared with what it's equivalent to, cosec squared x minus 1 minus 3 cosec x plus 3 equals 0. Just rearrange this to make it look more like a quadratic. Plus 2 equals 0. Now factorize cosec. I think it'll be a double negative on this one, minus 2 and minus 1. So therefore cosec is equal to 2 and cosec is equal to 1. Now we'll turn it into sine, so it's going to be sine x equals half, and sine x equals 1. So now we'll find the solutions to this, and it's going to be a radians mode, so it's going to be pi by 6 and 5 pi by 6, or it's going to be x equals pi by 2. Because that's the only time it will equal 1 on the sine graph. And there we are, that's the answer to this question here. So in this question we had to turn the quadratic one into the linear one, like we generally have to do using an identity. Alright, let's move on to the next one. Now, in this case, we've got a linear one of tan, so we're going to have to turn the sec squared into a tan. So we're going to change this one here, because the linear one is already tan. We can't change the linear one at all. So, in this question then, we'll remember that it's 1 plus tan squared x that equals sec squared. That's just a rule that you can remember. So, in this question, I'm going to then change this into this thing here. So I'll have then 4 tan squareds minus 3 tan x, and then I'll have a plus 1 from the sec squared equals 2, and then I'll take away the 2 onto the other side, so it'll be 4 tan x, 4 tan squared x minus 3 tan x minus 1 equals 0. So we take away 2 from both sides. Now let's factorize 4 tan x and I think it's going to be minus 1 on this side and a plus 1 on this side. So either we have tan equals minus a quarter or tan equals 1. That one's an easy one. That's going to be pi by 4, or add on another pi, 5 pi by 4. For this one here, we'll need to use a calculator and make sure we're in radians mode, and we are still. Tan inverse of minus 0.25, or minus a quarter. And we get first solution of minus 0.245, but that's not going to be a final solution because it's outside of the domain. Let's add on pi, and we get 2.90, and then add on another pi to get to the next solution, 6.04. So we've got 4 solutions here, 2 on this side, 2 on this side, and there we are. That's the answer to this question. Alright, let's move on to the next one then, and we've got a 2x inside there, so that means the first thing I'll change is that my angle is a 2x angle, and it's going to be from minus 2 pi up to 2 pi. And then the question doesn't really change compared to normal really, we'll just half all our answers at the end, so I'm going to turn the cot squared into a cosec squared, so I remember that the rule is 1 plus cot squared x, or 2x, doesn't really matter, equals cosec squared x. So I'm going to turn, it's going to be take away the 1 onto the other side, so it's going to be cosec squared 2x minus 1, but I'll include it with this minus 1 back here, plus cosec 2x minus 2 equals 0, because when I move this 1 onto the other side it'll be minus 1, and then link it with this minus 1 to make it minus 2. Now we're going to start factorizing. Cosec 2x, cosec 2x, and in one bracket it's going to be plus 2, in one bracket it'll be minus 1. So either cosec 2x equals minus 2, or cosec 2x equals 1, in which case we get sine 2x equals 1, or sine 2x equals minus a half. So in the first solution we're going to get solutions for 2x, which are going to be pi by 2. Let's just draw out the sine curve, that would probably simplify things. So it's going to be sine up to 2 pi, sine back to 2 pi. It's the only time it reaches 1 is at pi by 2 and minus 3 pi by 2. And the next one is 2x equals, let's do this on the calculator just to make double sure, minus 0.5, minus pi by 6. That will be this solution down here. This solution down here will be minus 5 pi by 6. This solution up here will be 7 pi by 6. And this solution right up the end here, that will all give us a half as minus a half as the output, will be 11 pi by 6. The last thing to do will be to half all of these answers, because in this whole question it was all 2x as the angle, and we need to find out what x is. So it'll be minus pi by 12, minus 5 pi by 12, 7 pi by 12, 11 pi by 12, pi by 4, and minus 3 pi by 4. And there we are. These are the 6 answers to solving this question. So quite a difficult one there, but again it's just using the concept of using 1 plus cos squared, 1 plus cot squared equals cosec squared to replace the quadratic one with, so it matches up then with the linear one. Let's move on to the next question, and we've got a slightly difficult one here. I think what we'll do first is we'll rewrite the sec as cos, so we'll write it as 8 sine squared x plus 1 over cos equals 8. Okay, the next thing to do will probably be to multiply through by cos, I reckon. So it would be 8 sine squared x cos x, and then plus 1 equals 8. The next thing to do will probably be, I want to turn everything into cos ideally, so it would be 8 bracket 1 minus cos squared cos x plus 1 equals 8. So I've missed out something here, 8 cos x the next thing will be to expand these brackets, so it would be 8 cos x, because I have to expand something quite difficult here. It would be the 8 expanded with the 1, but then expand it with the cos at the back, and then 8 expand it with the minus cos squared and expand it with the cos as well. So that would be minus 8 cos cubed x. Then it would be the add the 1, and then it would be equals 8 cos x. Then I can cancel out the 8 cos x's from both sides, because I just take away 8 cos x from both sides. So that will leave me with minus 8 cos cubed equals, so plus 1 equals 0. Move that negative expression onto the right hand side to make it positive. Divide by 8. And then cube root it. So I'm then going to get cos x equals a half. Not plus or minus a half, just a half, because it doesn't have the plus or minus effect when you cube root things. So if I had room below, I'd carry on below, but I'll just fit it in this corner over here now. The solutions to this equation here are pi by 3. It would then be 2 pi, so no, and then be minus pi by 3. So these are the two solutions to this equation here. So that was quite a difficult one actually. I didn't expect it to go into cubics, but what it did do is it nicely formed quite a simple cubic that I could quite easily solve there. So there we are, that's the answer for that question. Let's now move on to the next one. And the next one has, let's write it as 3 over sine squared minus 4 sine squared equals 1. And I think what we'll do is we'll times everything by sine squared, and we'll make ourselves a kind of quadratic, but it will be a quadratic to the power of 4, if that makes any sense. So it'll be 3 minus 4 sine to the power of 4, because I'm multiplying by sine squared, equals sine squared. The next thing we'll do is we'll move everything onto the right hand side. So 4 sine squared, so 4 sine to the power of 4 plus sine squared minus 3. The next thing we'll do is we will start to try and factorize. So what we'll do is we'll put it as 4 sine squared. So we'll factorize it like it's a quadratic, but using sine squareds in the bracket. Now what could we possibly do here? I reckon if we put the minus 3 here and the plus 1 here, that will give us 4 sine squared, but then take away 3 sine squared, that will give us plus 1 sine squared. Lovely, good stuff. So either we have sine squared x equals 3/4, or sine squared x equals minus 1. Now that won't happen until we go into imaginary numbers, or if you're in further maths you might want to try and solve that, but we won't go into imaginary numbers on that side there, so we have no solutions here, because you can't square root something to give you a minus 1. We could do it here, where we have sine x equals root 3 over 2, and plus or minus, because we're square rooting. So we've got two equations for the price of one here. We've got sine x equals positive root 3 over 2, in which case we have solutions of pi by 3 and 2 pi by 3. I'm just going to double check that on the calculator. Radians mode, sine inverse root 3 over 2. Yeah, that's pi by 3. And then the next one is going to be x. So the next little equation is sine x equals minus root 3 over 2 for the negative part of this original equation here, in which case we're going to get x equals minus pi by 3 and minus 2 pi by 3 as well. So there we are. These are the 4 solutions for this trigonometric equation here. So a little bit of a tricky one, this one. We had to go all the way to the power 4 on this one, but then we could factorize it in sine squareds, and then it made the question a little bit easier. If you've ever got something squared equaling a negative number, remember, there are no solutions there unless you're in imaginary numbers. Okay, let's move on to the second to last question. This question I found was actually the hardest of the whole worksheet, because there's no formula that directly links sec squared and cosec squared. You can't do a sine squared plus cos squared equals 1 and somehow connect them like that. But something they are connected to is something to do with tan. Now if you remember, it's 1 plus tan squared x that equals sec squared. And for the cosec one, it's 1 plus cot squared that equals cosec squared. So then actually, we can then, if we change this into tan, cosec squared into cot, and then everything's in terms of a tan in this question then. So it's 9 bracket sec squared, which is 1 plus tan squared x, minus 8 equals cosec squared, which is 1 plus cot squared. And now this question is turned into a tan question. So let's expand the brackets. 9 plus 9 tan squared x minus 8 equals 1 plus cot squared x. The next thing we'll do is we'll spot, so we've got a 9 minus 8, which is 1, which will cancel out with the 1 on that side. So actually all the numbers will now disappear. 9 tan squared x equals cot squared x. Multiply the tan squared on both sides. You'll get 9 tan to the power of 4 x equals 1. So what I've done here is I've multiplied by tan squared on both sides, because this here is 1 over tan squared. Divide by the 9, and then square root it once. So that'll be plus or minus 1/3. And then square root it again, and you'll get tan x equals plus or minus 1/√3. And then two solutions that are imaginary. So now what we've got to do is solve two equations. Tan x equals 1/√3. And we know the answer to that. That's going to be 30 and 210. And the next solution will be to tan x equals minus 1/√3, which will first of all give you minus 30, but then that's not allowed, so then it would be 150 and then 330. And there we are. These are the answers to this question. This one was a real tough one. Very well done if you got that, but don't worry if you've had to come to this video to find the answer to that, because even I found it really quite tough there. So in the future, what do we need to know? We need to know that there is a way to connect sec squared and cosec squared, and it's through two tan formulas. Okay. All right. And let's move on to the final question, and this one doesn't look as bad as the previous one. Cosec has a formula that links to cot. It goes 1 plus cot squared x equals cosec squared x. So cosec squared is going to be then 1 plus cot squared 3x minus √3 cot 3x. Minus 1 equals 0. I suppose I got a bit excited here. The first thing I really should have done was to expand the domain here to a 3x. So it's now from minus 3 pi to 3 pi. The next thing I've got is I've got a 1 and a minus 1 here, so those two will cancel out. So it's going to be cot squared 3x minus √3 cot 3x. Now we don't cancel out a cot here, we factorize out a cot here. So it's cot 3x brackets cot 3x minus √3 equals 0. So either this thing or this thing will multiply to make 0, so therefore one of them equals 0. So therefore cot 3x equals 0. And remember, the special trick with this one is to turn it into cos 3x over sine 3x equals 0. Now if you've got a fraction that equals 0, it's the numerator that equals 0. It doesn't matter what the denominator is. So therefore we've got 3x equals what angle will give you 0 on the cos graph, and that will be pi by 2. Let's just imagine it. It's pi by 2, 3 pi by 2. And then it's going to be 5 pi by 2. And then that'll be up until 3 pi. Let's go do the downwards ones now. Pi by 2, minus pi by 2, minus 3 pi by 2, and minus 5 pi by 2. The next one that needs doing is this formula here. So that's going to be tan 3x equals 1/√3. So therefore 3x will give you answers of, let's just do it on the calculator just to make double sure I'm doing this all right, 1/√3. That'll be pi by 6. And then we need to continue to add pi, because this is a tan graph. So it's going to be, add pi, we get 7 pi by 6. And then add another 6 on the top there, 13 pi by 6. Any more and you'll get too far along to 3 pi, because you'll get to 19 pi by 6, which is overboard. So that'll be minus 5 pi by 6. Take away another pi, which will get you down to minus 11 pi by 6. And another one, minus 17 pi by 6. Wow, we've got tons of answers here. And we haven't even divided by 3 yet, because it's a 3x angle, isn't it? So our final answers are going to go in this box here, because we're going to divide all of them by 3 now. So x equals pi by 18, 7 pi by 18, 13 pi by 18, minus 5 pi by 18, minus 11 pi by 18, minus 17 pi by 18. That's all of these ones. Let's now do all of these ones. Minus pi by 6, minus 3 pi by 6, minus pi by 2, minus 5 pi by 6. So they're all positive, aren't they? Positive, 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 and then it would be minus pi by 6. Oh, you could have just kept them, couldn't we? Minus 3 pi by 6 and minus 5 pi by 6. Phew, there we are. I'm just going to check one of the ones at random. Let's pick this last one here. So I'm going to do... no, actually, no, that would be too long to do that. Okay, so there we are. That would be the answer to this question here. And that's all of the questions from this worksheet. I am absolutely knackered. I don't know about you. But there we are. That's all of these questions answered. Hopefully you are now a bit more confident in solving equations related to cosec, sec and cot. We've done as many as we can, and we've gone up to a really high level of difficulty here. So you should be really pleased with yourselves. Lovely. Thanks very much for watching. Hopefully this video has been helpful, and please feel free to come back to it if you need any more practice in the future. Thanks for watching.